Chapter 6, Proteins. Proteins are different than lipids and carbohydrates. Their structure is more complicated, and they have many functions in our body. Although they can provide us with energy when necessary, they have much more important functions, like working as enzymes, hormones, and antibodies, providing structure to skin, muscles, tendons, and ligaments, acting as buffers, and aiding in fluid balance and blood clotting. The structure of proteins is more complex than that of carbohydrates and lipids. One of the key differences is nitrogen. Nitrogen is part of the side chain on an amino acid. Amino acids linked together make up a protein. In this picture here, also on page 181, you will see three amino acids, valine, leucine, and tyrosine. They're joined together via a peptide bond to form a strand of amino acids in the basic structure of proteins. A protein doesn't exist in a straight line, though. It coils on itself, then folds. The final structure is a completed protein, and the shape of the protein helps determine its function. Denaturation of proteins is the uncoiling of them. It's like going backwards, starting with the completed protein, unfolding it, and then uncoiling it. The protein can no longer function. Heat, acid, alcohol, and I don't mean beer, bases, and heavy metals will all denature proteins. In the picture here, also on page 184, you can see the clear egg white before it's cooked and how it turns solid and white after it's cooked. The protein in the egg white has been denatured by heat. Another example is acid. If you were to imagine an acid hitting your skin, what happens? Most of us can only imagine what the movies show us, but it's partially true. The acid looks like it's dissolving the skin. The acid is in fact denaturing the protein collagen, which makes up a large portion of the skin. Heavy metals, like lead and mercury, are toxic to us because when they enter our system, they come into contact with our enzymes, which are proteins, and they denature them, causing them not to function. The body does not want to use protein for energy. Proteins are just too valuable. Carbohydrates feed the brain, and fats are our best source of energy, and most of us have plenty of them. Using protein for energy is a last resort. We don't store protein like we do carbohydrates, in the form of glycogen and fat, as triglycerides and fat cells. To use protein for energy, our body must dismantle body proteins like blood proteins and proteins to make muscles and other structures to obtain the amino acids to supply 4 calories per gram of energy. It's not very efficient. How much protein should we eat? There are two ways to figure this out, and most students hate both ways, because both involve math. The first calculation is based on weight. The recommendation is 0.8 grams of protein per kilogram. Let's start with a 130-pound woman, given as an example in the lecture notes. The first thing we have to do is convert kilograms. There are 2.2 pounds per kilogram. So we divide 130 pounds by 2.2, and this gives us 59 kilograms. Now we can proceed. This 59 kilogram woman requires 0.8 grams of protein for every kilogram that she weighs. And since she weighs 59 kilograms, we need to multiply 0.8 grams per kilogram times 59 kilograms to get 47 grams. That's 47 grams of protein. So her recommended protein, based on her weight, is 47 grams. This calculation generally gives us the low end of the protein recommendation. Now let's look at a second way to calculate protein recommendations. Calculations based on percentage of total calories. The recommendation is 10 to 35% of total calories. This is the way the carbohydrates and fat recommendations have been presented. But we're going to take this one step further and find the number of grams of protein an individual needs. This is independent from a person's weight. Let's say this woman requires 1,800 calories a day. If we were to find the absolute minimum amount of protein she could eat and still maintain a healthy diet, we would take 10% and multiply this by 1,800. This gives us 180. She needs 180 calories of protein per day minimum. If there are 4 calories for every gram of protein, the 180 divided by 4 equals 45 grams of protein. Notice that this is very similar for her recommendation based on weight. To find the maximum amount for her, we would multiply 1,800 calories by 35%, or 0.35. 1,800 times 0.35 equals 630 calories from protein. If we divide 630 by 4, because there are still 4 calories in every gram of protein, we get 158 grams of protein. Her recommended range for protein intake, based on percentage of total calories, is 45 to 158 grams. It's a big range, but it allows people to vary their intake based on their lifestyle and diet choices and still remain in a healthy range. Now to finish up, a few words on protein energy malnutrition. If we look at this little guy here, he is suffering from marasmus. Marasmus is severe malnutrition, usually beginning at birth. He has a lack of protein and calories. He's extremely thin with matchstick arms, and there's no swelling. This type of PEM can go to the point of no return. And what I mean by this is once the body starts to break down its own proteins, which make up the intestines, for energy, he can no longer absorb food or nutrients. Now this girl is suffering from kwashiorkor. Kwashiorkor usually begins after a sudden halt in protein intake. She may still get enough calories in, but not enough protein. It's very common when a mother who is breastfeeding her child has another child. She stops breastfeeding the first child and starts feeding the newborn. It is characterized by a swollen belly. This is in part due to a fatty liver, but also because proteins help to maintain fluid balance. When there's a lack of protein in the bloodstream, the fluid gets leaked out into the tissues and causes edema. That's it for Chapter 6.